Hello, in this video we will discuss data analysis and reporting of reliability data, validity information, as well as we will discuss differences in variables. We will go over validity, reliability, and then when we discuss differences we will look very briefly at analysis of variance or ANOVA, but primarily we will look at t-tests. When we address validity in survey data, two types of validity that are good to know about. They're both criterion validity. One is called concurrent validity, which a good example would be if you wanted to create, let's say, a new assessment measuring something that already exists and already is being measured by a different assessment. A reason why you might want to do that is, let's say, for instance, the old assessment is extremely long. You want to create a shorter one. That way you'll improve participation rate. Or perhaps it's for a new culture, it's a different country, so you want to create a new assessment that is in a different language. Or perhaps a factor is not being addressed, such as there was a servant leadership measures out, there were several servant leadership measures out there that did not address religion or religiosity, and therefore I created a new servant leadership measure. It was based on, or it was similar to an old one, but it had the new factor. So in this case, in order to establish concurrent validity, what I ended up doing is surveying participants using both the pre-established measure, the previously established measure, as well as my new measure, and correlated the results, and therefore it showed that it was a valid measure. Also predictive validity, and that's where you have, you look at scores over time, and ideally your measure will you'll be able to predict certain behaviors over time. That's predictive validity. When we look at reliability, common, or perhaps even the most common way that reliability is established within a measure is using Cronbach's alpha coefficient. What is this? It's relatively simple to understand. I shouldn't maybe use the word simple, but basically what it is if you have multiple items that are assessing a certain construct. In the example to the right, we have self-efficacy is being assessed. There are actually 10 items for self-efficacy, and in order to demonstrate their reliability, what we are going to do is run Cronbach's alpha and look to see if each of these items have similar responses. That's what Cronbach's alpha is doing. And then you get a score, which is, there's that blue box around the scale of 0.854. That is the Cronbach's alpha score. And so what it shows is that those 10 items have similar responses, therefore they're considered reliable. If one of those was, let's say, poorly worded and was not really addressing self-efficacy, then what might end up happening is might dramatically lower that score. And then when you're using software to assess Cronbach's alpha, you have this feature where it's, if the item is dropped, then what would your Cronbach's alpha score be? And so that's right here on the bottom right. And so essentially what happens is then you would know, hey, I need to remove this item from this measure, perhaps never use it again, or reword it, do something else to it, so that way it's more reliable and it's more consistent with the other items. In order to be in the area of being an acceptable score, it should be 0.7 or higher. 0.8 or higher is good, 0.9 or higher is excellent. If you're in the realm of 0.5 or above, it's poor. If it's near 0.5, it's questionable in the 0.6 area. But if it's less than 0.5, that's what's considered unacceptable. As we look at differences, let's, for example, if you have, perhaps you have a male-female group, you have an age group, older, younger, you have one, let's say one location over another location, if you're looking at locations within the workplace, different branch offices and such. When you're looking at two different groups, you can do a t-test. One sample t-test is going to perhaps compare, let's say, scores that you get in a survey and compare that to an established baseline or something. Independent samples, t-test, very common because that would be done if you submit one survey, you get results, and then now you want to compare, again, two groups from that, male, female, something like that. Or a paired sample t-test is another example. And then again, an analysis of variance, like I mentioned in my introduction there, that looks at several different groups. So the example to the right, what we have is the number one. It's showing where there is not a difference between our straight and not straight groups on self-efficacy because the p-value is 0.110. However, for the construct of anticipated discrimination, the p-value is less than 0.05. It's actually less than 0.001. And so therefore that is statistically significant. And if you look at the mean values, you can see where the self-efficacy, your mean values for not straight is 31.4, your mean value for straight is 32.27. Well, there's not much of a difference between those. However, there is a rather large difference between the straight group, 9.70 for anticipated discrimination, and 13.5 for the not straight group. What that's showing is that this higher number shows a higher degree of anticipated discrimination and actually much higher than the straight group. Now we run the independent samples t-test, and sure enough, the results confirm that by being statistically significant. T-test reporting, how do you report t-test results? So here's a detailed breakdown of that. The information you get in the independent samples t-test results includes five different bits of information that are valuable. The statistic, number one, that's your t-value. That's your statistic. Like you'd have for a correlation, you'd have a p-value. ANOVA, you'd have an f-value, and so on. You have the df. That's number two. That's your degrees of freedom. You have the p-value, which is your level if it's significant or not. You have the mean scores, which we showed you in the last example. And then you have your standard deviation, number 5. How would you write this up? Well, in this case, we are looking at t-tests that were run on two different variables. We find that one is significant, so we write it up as a 2-sample t-test was performed to compare differences in self-efficacy anticipated discrimination levels between straight and not straight participants. Very straightforward sentence here. Then we state the results. There was a significant difference in anticipated discrimination levels between straight, and so we show the mean score for the straight group as well as the standard deviation. We get that from our table up here. And then, so between the straight and the not straight group or participants. And so then we get the mean scores for the not straight, 13.5, as well as the standard deviation, 7.08. And then we report the results, which the degrees of freedom is 438. If you go back to your table, you see that here for number 2, degrees of freedom. The statistic is negative 3.49. So we find that right here for the anticipated discrimination group. And with a p-value of less than 0.001. Here's one more example. This is an example of where it was not significant. So an independent samples t-test was performed to compare differences in self-efficacy levels between straight and not straight participants. There was not a significant difference in self-efficacy levels between straight and not straight participants. And then again, we fill out that information. That is how t-tests are written up. And you will notice that we very clearly align the table. I do not have the table here displayed in APA style, but this would be the table that would be generated, in this case using Jamovi software. And this is how it will be written up. It's very straight, very direct, and very simple, I guess you could say, from an analysis perspective, simple to understand, very direct, says what occurred. I hope that helps you better understand these concepts of reliability, validity, and differences in your scores.